Okay, we are live now. Hello, I am Ahmet Kel from Turkey, and Stuart former with me. Yeah, Stuart.
Hello.
I'm going to explain how I use the PixInsight. It will be a beginner level. So I just tried to explain how I use this program to process my image. Okay, I think.
Okay, well, yeah, and you're doing this in English because you did one in Turkish, and I
Yes.
gave you a bunch of crap about it because only Turkish people can understand it. And I said, well, you know, it's.
So I hope I can explain it in English.
All right, and I can count to 3 in Turkish, I think. So.
Yeah, that's good. And let me share my screen. Okay, I think everyone can see my desktop.
Mm-hmm. Do you set up process icons ahead of time, or do you go just through the Process Explorer?
I have some process icons, but generally use the Process Explorer.
Mm-hmm.
So I'll go with the Process Explorer, but sometimes maybe I will load some icons, process icons. So, okay, let's first look at the window menus. There are some menus here on the left bar. You see, in Process Console. We can see the script, what's going on the program. That it shows which process is being run, so we can follow the process from this window. And there is a Process Explorer here. In this menu, we can find all process. There is a lot of tools here, and we will call like this one, call process from here, and then use it on our pictures. And here's another menu, Format Explorer, and we can edit the preference of the file format here, like how the files save. Let's say the quality of JPEG. This is the default value. You can give the default value here. And most important thing is here is the DSLR RAW. Actually, this is show how we open the RAW files. I assume that we are using the DSLR, so I will show you how we choose the format preference for the RAW files.
Yeah, I have a CCD, but a lot of people do have DSLR.
Yes, many people use DSLR. So I'm going to show you how settings should be to open the files properly. So by default, there is the use camera white balance settings is checked, but most of us use modded DSLR. So camera white balance is generally not correct. So we should remove the tick here, and also we should select the create raw pair image with this option. It's use no interpolation, no debugger, It just create a picture from bare matrix. So another options, no black point correction, so it will not do any correction of the image.
Does that mean you'll debayer it later?
Yes, yes. There is a debayering options or tools. It will debayer the image. We will do that later. Okay.
Sounds good.
When we ready, we can go to the next step. There is a scripts here. There's a lot of scripts we can use. The first we use batch pre-processing. With this tool, we can calibrate our red frames. Also, we can create master bias darks and flats. First, I'm going to show you how to create master frames. Let's select bias frames first. Okay. PixInsight says that bias frames should be much higher than dark frames. So let's say you have 30 dark frames, so you should have more than 30 bias frames.
Yeah, so, bias frames are so easy to shoot that I usually shoot about 100 of them.
Yes, so there is, I think, 80 here. So let's select all of them. And the second card here, the dark. I press add dark and select the dark frames. So you see there's a lot of different dark frames. But the PixInsight has an ability to scale the image. Let's say you have different exposure time, different ISO settings, different temperatures. So the program can scale the noise, so to match the files. So let's say you take your lights at temperature 20 degrees, but your dark frames, let's say 15 degrees. PixInsight can scale the dark to 20 degree, so you can use it for calibration. So I just select one of them. Let's say dark 60 seconds ISO 800. So here is the dark frames. And last one, flats. Here I select flat files. Okay. I'm not going to add lights here right now. I'm just going to create master frames.
Just master calibration frames?
Yes, master calibration. So I just select an output directory. Calibration. And also the options here should be like this. Okay. And when we run, it warns us that there is no light. It's okay. We are just going to create master frames. It takes some time, so I'm going to abort this and just show, because I did it before. After the process finish, you have 3 files, like that one here, bias, dark, and flat. You have these 3 files, so I just select bias and dark and flat. Okay. And we check the use master bias, master dark, master flat options here. So you can see there's a blue star appeared here. It means it's a master frame. So now we can calibrate our lights with the master frames. I create masters because I take several pictures overnight, so I don't want to process all bias dark flats again and again. So doing that, you can save time. Okay.
Right.
And I'm gonna add the light frames. Here the lights. Select them. Okay. We are going to select the output, where we are gonna use this here. Okay. We select the folder. And also there is a image registration options here. I left it default, so you can select one of the image for the reference image for the registration. I just clicked one of them, so you can see.
Do you click the best one, or do you just click one
Actually,
at random?
I generally look at. I use DSS for the given, let's say, points for the image, and I select the best picture. So let's say this is the best one. Okay. After that, we can run script. Just select the output, select the reference image, and we are ready now. Okay, it starts calibrating image. First, it creates, it debayer the image, and then it registers the debayer image.
So you're debayering it now?
It takes time. Yeah, so it takes time.
And which camera are you using?
Canon T2i.
So it's the RGB, right?
Yes, RGB. Okay. So the bayer pattern also can be selected here. It's default. It's come with the RGB. Canon has the same pattern. So if you have different camera with different pattern, you can select it here. Okay. And here is the files. It put the light frames here. After the light frames also calibrated with the bias dark and flat. So after the calibration process, it deburied all of them and put it on the deburied folder. And after it will align all the pictures with the selected reference file.
Mm-hmm.
So here's the registered, or other words, aligned pictures. So we are ready to stack this image. On the Process Explorer, we select Image Integration here. And in the Image Integration menu, I select Add Files, and here is our registered frames. I select them here. Okay. So you can select reference, or it automatically select the first one. But you can select another one. I was not using guiding scope, so the pictures are slightly moving towards some direction. So I generally choose the middle of the time. Let's say start from 110 and end 117. Let's say so. I select 114. Okay.
Okay.
So so it gives best alignment. And anyway, this first one selected. And on the image integration options here, you select average and wait for noise evaluation here. Okay, so I generate integrated image and evaluate noise options should be selected. And in the second one, pixel ejection, you will select Winsorite Sigma clipping. It will use the Sigma clipping algorithm to reject the hot and cold pixels. So clip low, clip high pixels should be selected. And here we can select the sigma values. Generally, 3, around 3 or 4 is okay. But if you have some hot pixels after the integration, you can try different values. But generally, these values are okay. Now we are ready to integrate. Okay, and press the apply global. So it starts integrating the image. So, and again, I'm going to cancel this one because it takes time. So here is the integrated image. So you see, it's a linear image, so you don't see anything here now.
Right.
But there is a tool called ScreenTransferFunction. With this tool, Okay. The tool just stretch the image for the to see the with our eye, because we can't see the linear image. So it just it's not do anything of the file. It for just showing the image.
Right. It's a non-linear look of what your image may look like, but you're still in the linear state.
Yes, yes, right. So it helps us to see what's going on the image. So there's some alignment error here. So I'm gonna crop the file. I'm using DynamicCrop tool. Here, just select the left up corner, go to down here, and press execute. So it crops the corners. Okay. And there is actually my flats. I think my flats are good. So there are not much vignetting around picture.
Vignetting, yeah.
Vignetting, yes, not that much, but there still exists. So we are gonna use DynamicBackgroundExtraction tool. This tool will help us to remove the vignetting. So first we select the sample generation here. We can put the reference manually, but I think it takes time. So there is a options here. Sample generation will automatically generate the sample points. So I select the sample per row, let's say 20. Radius, default sample radius, it's how much data it will look for the samples. So I think 15 is okay. If you grow this value, you know, if there are too much stars, so it may gives you wrong results. So I think 15 is okay.
And you can manually put samples down, right?
Yes, you can put manually, but it takes time. With this sample generation, it will automatically generate samples for us. Let's generate here. So it puts the samples, but you see it didn't put samples everywhere. We need samples background area. So there is an option minimum sample weight. If we decrease this value, let's say 250, and resize all. Sorry, generate again. So now it puts the all samples.
And it's avoiding the image. I mean the galaxy.
Yes. We should avoid putting the sample around the galaxy. So
Now, what happens if you have, say, like an image that's something that fills the whole screen, like a wispy nebula or whatever?
Mm-hmm.
Can you use it then? You know,
For
where you're...
nebula, we should avoid putting this point on the nebula. So if there's not much empty background, it's hard to do the background extraction, I think.
Okay.
But with this image, I'm just going to remove the points around the galaxy.
So just the ones where it has, you don't want to get rid of the edge of the galaxy there.
Yes, yes.
Right.
Because it will give a wrong reference. So, because the program needs just the real background. If you put the sample point on a galaxy or nebula, it thinks it's a background, so it will show, it will give us a maybe worst result.
Right.
Okay. So I'm not going to remove all of them because it takes time. There's also another option I want to show you. There's a tolerance, because if vignetting is that so much, so you will see that some sample points are seem red. Let's say like this one. Okay. So using tolerance options, we can make them white again. Okay. If you
Now,
see,
what does that do to it? Does that decrease the sensitivity or increase the sensitivity?
Actually, let's look at one of sample. I select this one. Okay. If here black means there is it will not look that area. Okay.
There's a star there or something.
Yes. Yes. So it will consider the white areas. Okay. So if we decrease this value, let's say 0.2, you see it's going to black.
Oh, I see.
So this weight will decrease. Okay. So if
so white means it'll take it in, black means it ignores it.
Sorry?
White means it uses it, and black means it ignores it.
Yes, yes, that's right.
Mm-hmm.
I think last thing we should do here is the target image correction. We should select the subtraction from the correction menu. And now we are ready to process. Just press the execute button.
And just to be clear, you want to do this in the linear state, not the non-linear state, correct?
Yes, yes, we are still in linear. And here is the result of dynamic background extraction. So, again, using screen transfer function. So this is the original image. And this is after the dynamic background extraction. This is the original.
A little hard.
You see the difference. Okay.
So that's after right there?
This after. But I think we.
And that's before?
This is after. This is before. But I think our sample point is not good. So I'm going to open. But I did before. I think this is better. Okay, I just close the other ones. I create this the correct settings before. Okay, I removed the sample points around the galaxy. So this is a better result. Okay.
Right.
We continue with this.
Right. So you just remove the sample points around the galaxy, so you don't get the
Yes. Now we are going to do the color correction because the color is not aligned. You know, it's a modified camera, so it's more sensitive in red, and the color is not calibrated. So we need to calibrate the color of the image. So first, we are going to use the background neutralization tool. This tool will actually the black point in the image should have the same RGB values, but since the colors are not calibrated, the black is actually not black in the image. But with the background neutralization tool, it will we are gonna show it a preview for the image as a reference, so that the tool can extract the background and neutralize the black points. So first we are gonna create a preview window. We can use here. There's a page and the plus icon here, or we can use Alt plus N button on the keyboard.
And what does that do?
Create a new
preview.
Yes, preview window. It should be away from the galaxy, and just it should should be background. Okay. So if you can put, let's say here is a good place. So I'm gonna select the reference image here. It's DB2 preview 1. This one, okay. So we don't need to change the other options. Just put the new instance icon, press and hold the left key, and put it here on the image. So its background neutralization is done. We may not see much change, much difference on the image, but this is the first step we should done for the color calibration.
So you do your background neutralization before the color calibration?
Yes, this is the first step we should done before the color calibration. And now we can use the color calibration tool. In color calibration tool, we are gonna solve this tool where is white and where is black. There is two menu here, white reference and background reference. We will create another previews image. For the reference, white reference, I will use the galaxy. So galaxy center is, I think, is better.
Reasonably white.
Yes. So for white reference, I will use this preview, and for background reference, I will use the preview 01, this one. I can also create extra preview for the background reference. I just need to use a script called preview aggregator. The preview aggregator tool will merge the preview in a one file. So I'm gonna merge the previews 1, 3, and 4. So I just remove the preview 2 because I'm gonna use it for white reference, but preview 1, 3, and 4 I'm gonna use for background reference. Okay. Here's the aggregated image. I'm going to use it for background reference. Okay. So on the right white reference, I select the preview 2. Okay. And background reference, I select the aggregated image here. Okay. On the white reference, there's option structure detection. If we want to use the only stars for the white reference, we can use these options, but since we have a bright galaxy, I remove these options. So we use the galaxy for the white reference. So, and there's also some options here for the reference, low limit, upper limit, and we should select the some values here. For example, for right reference, I checked the values, RGB values here. Moving the mouse, you see the RGB values shown on the toolbar. There is 0.006.
Oh yeah.
Yeah, 0.005.
Yeah.
Values. So we select the threshold here. We will select the lower limit, so it will use the pixels higher than that value as a white reference. So we don't need background for the white reference. We just need the galaxy. Okay. So I just select let's look at that again. 0.00, let's say 3. 0.003. Okay. And for the background, I check again here on the background preview. I look at that the background values around 0.001.
Where are you seeing that down on the bottom?
Yes, on the bottom. You can see the values. So let's say 0.003 for the upper limit for the white reference. 0.003 because it will reject the values upper than this, so it will not use the stars for the background reference.
Mm-hmm.
So I select also output white reference mask, output background reference mask, and we can see how it used the reference. I just hold the key and select the nearest instance and put it on the image. Okay. So here is the masks it used for the white reference. This here white means it will use it. It will use these points, and the black means it will no mean. It will not look at that area. Okay. So I think it's good. It's a good mask for the white reference.
We lost you. I think we lost Ahmet. Let's see if he comes back.
Stuart?
Yep, you dropped off for a second.
Yes, I just dropped. Here's the background reference. You see the stars are rejected. I think the options is okay. So I just use the second transfer function again. Okay, we can close the color calibration tool and the previews.
I'm going to keep going. I'm going to be back in 10 seconds. I just have to turn something off downstairs.
Okay. And the last thing we should do for the color calibration is a SCNR tool. In the image, there is much. Generally, there are much green because the Bayer pattern is RGB, so it collects double in the green channel than R and B. So these tools will eliminate the green. So just select instance and put on the image. And now calibration is done. So we can go other process. next tool is ATrousWaveletTransform. It's a noise reduction tool, and you see there is some noise on the picture. With this tool, we are going to reduce the noise. But we need to protect the bright areas, because the bright areas have a good SNR value, so we don't need to process these areas for the noise reduction. So I just use the inverted luminance mask. Just check select hold the key. Let's do it again. Hold the left key and leave it here, and it's create a clone image. So it's a linear, but we need a non-linear mask. So I'm going to first open a histogram transformation tool, and I press the left button here, the new instance. Settings will go to the histogram transform tool, and when I leave it here, okay. So I just reset. You can see it's a linear image, but we are going to make it non-linear. Okay. I just drag and drop the new instance icon here. Now it's create a non-linear image now, and I hold the file name and put it on the empty space here. It will create a mask. Okay. So what we need to protect the bright areas. So I just invert the mask. The top menu, you can see the mask options. Here there's the invert mask options. You can also use Shift Control I keyboard combination. Okay. Here now we protect the brighter area, and the noise reduction process will apply on the background. So there is also a tool icon here, show mask. So it just remove the not remove the mask, but just show off on the picture. Okay. So now we can apply the ATrousWaveletTransform to the image. In here, I select for scaling function P3 spline. Okay. And I select the layer 1, noise reduction. The pre-amount 1 is okay for this layer. And second layer, I select again noise reduction, but use the threshold value 2. And the third one, select noise reduction again, and threshold is 1 this time. And the last layer, again select noise reduction with 0.5 threshold and 0.66 for for the amount. So now we are ready to apply ATrousWaveletTransform function. I select the new instance and put it on the picture. Okay, we applied ATrousWaveletTransform function. Let's look at the difference. Here I undo and redo. You can see the noise are removed. Okay. So the next step, we are going to make the picture nonlinear. So here first I'm going to reset this and remove the mask also. Just close the mask so it removes. So there is two ways to create a nonlinear image. First, we can select the image from the menu here and just select the midpoint and pull it on the left side, and you'll see that the histogram is stretched. So I think it's okay for the first step. I just select and drag and drop the distance. So again, I first reset the options and move the midtone towards the left. So maybe you can see there is. You can also move the shadow on the right, but we should look the values here on the shadow. It says that there is 29 pixel is clipped. So here you can see how much pixel it's clipped. So if we move it much further, you see it's going to reject a lot of pixels clip. So I think here 29 pixels will be rejected, but there is about 10 million pixels, so it's okay.
Right, but you don't want to clip the blacks.
Yes. So I think it's okay now. So this now the image is nonlinear, so we can continue processing with this image. The other way to create a nonlinear image is to transfer the transfer function options to the histogram transformation tool. Let's undo. This is the linear image. We just select this auto stretch. Okay.
Right, now you're just sort of using the ScreenTransferFunction to get the linear state. Yeah, it's a little brighter.
Yes, it's a little brighter. So I generally use manual use histogram transformation manually. So but you can use this like just drag the process icon from the screen transfer function and drop it to the histogram transformation. And again we reset and drag and drop distance here. So now it's a non-linear with the screen transfer function settings, but I prefer the other way. Okay, so I again close this one because I already done this here. Yes. Okay. Now we have a non-linear image, and the next step is HDRMultiscaleTransform function. This tool will bring the details on core of the galaxy. Okay, default settings I just select lightness mask and light mask, and don't touch other values, but you can try different values to see the results. So it takes time to apply this process to whole image. So I just select a preview, Alt plus and button. Just select the core. Okay. So here we can try here. Yes. Okay. Here is the preview unread icon. You see, this is before and after. You can see how it changed the details.
But you lose you lose a little brightness in the core that way, right?
Yes, but it's bring the details.
Right.
Okay. So it's as I said, it takes time. So I'm going to open. I did before. Yes. This is the applied image, and the next step is let me check ACDNR, another noise reduction tool. Okay. First, we select the lightness mask preview, and here is the real-time preview button. And we press, it shows how the lightness mask is. So again, we need to protect the brighter area. So I just move the sliders. Okay, shadows, midtones. think it is okay. It will protect the galaxy, the brighter areas, and it will apply the noise reduction on the background. Okay.
Okay.
And uncheck the preview, close the real-time preview, and on the lightness, I select lightness mask. Just created, and standard deviation option we select for 2. Okay, we don't need to change the other options here. And in the chrominance, we again select the lightness mask and 3 for the standard deviation. So we are ready to apply this tool. Just drag and drop here. It takes about 2 or 3 hours to process an image for me. So I need a powerful computer, I think.
What are you using?
I have a iPad T400.
Mm-hmm.
Actually, it's a good. It's about 6 years old. Well, I think I need a better processor.
And how long does this process take usually for you?
Yes.
Make yourself a cup of coffee.
Yeah.
I've had Turkish coffee before. It like pours like ketchup. It's very thick.
Yeah.
Yeah.
Yeah, it's thick.
Yeah, Turkey ruined coffee for me, drinking for me forever, because now I like my coffee very, very strong.
Mm. But you cannot drink so much Turkish coffee.
Oh, I can.
Yeah. Yeah. Okay, here's the results. I'm not sure if you are able to see the difference.
A little hard on the screen.
Yes.
But
this is before, and this is after. It removes some noise.
Mm-hmm.
here. And the next step is local histogram equalization tool. Local histogram. This tool will bring some details on the picture. First, let's do it in the preview window. Select here. Okay. So for Canon radius, around 150 is okay. And for the amount, if you use a mask, you can use a bigger value like 0.8, 0.9 or 1. But if you don't use a mask, so it's better to use a lower value like 0.4, 0.3, let's say 0.4. Drag and drop. It's also takes a lot. I will not apply it on the whole image.
You're just applying it to the preview?
Yes, I just apply it to preview, but I will open the file I did before. Okay, here is the difference. This before, after. You see there is the structures are strong now. This is before, after. It brings some details here. See, and I'm gonna open the file I did before. Yeah, this one. I always put the name after I process. I save the files so you can see my steps in the file name. Okay. So after that, we can actually, you see the stars are big. We can reduce the star size. Okay. With StarMask, is the StarMask. We can create a mask, a star mask, and then using another tool called MorphologicalTransformation, we can reduce the size of the stars. So it will bring much details of the galaxy.
Cool.
And I just drag and drop. It again take time. So let me check if I already created a mask. I think I have. Okay. Open. Yes, this one. Yeah, after the process, you get a picture like this. This is a star mask.
Right.
So I just hold and put the empty space here, so it applies the mask on the image. I just don't want to see the red, so I hide the mask. Okay. Now we can use morphological transformation function in order to reduce the size of the stars. So in this tool, we select erosion minimum for the operator, and for the amount, I think 0.60 is okay. So in the stack element, 525 elements should be selected, and weighs 101. So the options is okay. And I also want to show a process icon. You can save the settings. Just select the new instance and put it on the empty space. So it creates a process icon. So whenever you call this process, it brings the options you created. So you don't need always to select all options again and again. You can just use the process icon. So I just select save this icon and save. So let's do it again. Just process icon, load process icon. Select the process icon we created, and just double click. So you have the options here. So I just drag and drop. Okay. Now this is before and after.
Go to before again. Your internet's a little slow.
Oh, okay. This is the before.
Mm-hmm.
So after we applied, you see the stars are smaller.
Mm-hmm.
Okay. So you can maybe apply a few times to reduce the star size again. So the next step is the color curve transformation for give some color to the image, because now it's not there is not much color here. Select curve transformation and I select the saturation here. Now we can change the saturation of the image. I just select the image. Yes. In the real-time preview, you can see. Okay. I think this is okay. So drag and drop. Now we have a color image, but the background also colored. Maybe we can use a mask to protect the background. So I will undo and create a luminance mask. There is a icon here, extract CIL component. It will create a luminance file. Yeah, here. So I will use HistogramTransformation for make it a little dark. That's okay.
You're creating a mask, correct?
Yes, this is a luminance mask.
Yeah, so that's, yes, because you do, normally, just to describe, you do not want to clip like you just did.
We can clip for the luminance
mask. You can.
Just yes, mask.
Right,
but
just for the mask.
We try to protect background.
Right, exactly.
Yes.
But I see sometimes I see astrophotographers and they try to increase their contrast, beginning astrophotographers, and what they do is they make black and it clips it, and it looks terrible. And it just, because when you look up in the sky is not black. You know, the sky is gray.
There is an argument, I think, because the sky looks brown, I think.
Yeah, brown, gray, yeah, but not black. Yeah.
So there's an argument for that. So let's apply the curve transformation with the mask. So here's the preview. Apply. Okay. Maybe we can apply a few times.
Apply what? I'm sorry?
Maybe we can apply a few times again. But there is not much difference because we protect, I think, protect too much the image. I'm not sure if you can see the difference. This is before, after, before.
Yeah, it's subtle.
Yeah, maybe we can try a few times. Okay. So I think we are finished.
Okay.
Here. I use Photoshop after that point. Just do a few steps. Just like I use sometimes I use high pass filter to reveal more details. But this is what I do in the PixInsight.
Well, cool.
Okay.
I think this will be yeah, certainly helpful to me, and it'll be helpful to others as well.
Yeah. This is actually, there's a lot of tools I haven't touched yet, you know.
Well, what might be helpful when you post this on your YouTube site is just make a list of the steps that you just did
Yes, yes.
in the comments.
It will automatically will put in my YouTube channel, so everyone can see it again.
Mm-hmm.
So I think we are done.
Okay. Well, thank you, Ahmed.
And
thank you for doing it in English.
Yes. I hope I can explain my techniques. Sometimes it's hard for me to speak English,
Mm-hmm.
because I think in Turkish and translate it in English. And
Right.
Yeah.
No, your English is fine. It's certainly better than my Turkish.
Okay. And thank you.
Yeah.
Thank you, sir.
All right. Thank you.
And thank you for all our viewers. And see you another hangout.
All right. Sweet. All right. Bye, everybody.
Bye.
You're still alive.
Press stop. Press stop.
You're still alive.
Stopping. Says.